Okay, so I want to summarize all the transformations to quadratics. So we have the parent function y equals x squared. We know that if we add something to that, call it k, it shifts it up and down, so your parabola ends up looking like this, or shifts it down, looks like this. Y equals x minus h squared. That's a horizontal shift, so that shifts your parabola left and right, so keeps its general shape, shifts it that way or shifts it this way depending on what h is. And then we also looked at y equals ax squared and how that affects the graph. It can make the graph wider if it's a whole number. It can make it narrow if it's a, I'm sorry, I said that wrong. It would make it wider if it's a fraction. It will make it narrow if it's a whole number. And if it's negative, it can flip the graph upside down. Okay, so that's A. And then if you put it all together, you get y equals a x minus h squared plus k. And so that shows you all the transformations, and I can give you an example. Y equals negative 2x plus 3 squared minus 4. And so if I wanted to graph that, I know that it's going to look like 4 units down, 1, 2, 3, 4, 3 units to the left, 1, 2, 3. So that's where my vertex is at. This is actually in vertex form, so I know the vertex is at negative 3, negative 4. And I know it's upside down, and I know that it's kind of narrow, so it looks like this. If I want to graph it even better than that, I would make a table of values, and I would start with the vertex. I know the vertex is at negative 3, negative 4. If I want to check that to make sure, I can plug negative 3 in here. Plus 3 is 0. Squared is 0. Times negative 2 is 0. Minus 4 is negative 4. So I can see that negative 3, negative 4 is the solution, and it is the vertex right there. So now I only need 2 more points if I want to get a nice graph either to the left or to the right. If I plug in negative 2, which is 1 step to the right, negative 2 plus 3 is 1. 1 squared is 1. Times negative 2 is negative 2. Minus 4 is negative 6. So negative 1, negative 6, right about here. And then I know because of symmetry, this is my axis of symmetry, and it is at x equals negative 3. I know that if I'm 1 step to the right, then there must be the same solution 1 step to the left. So had I plugged in negative 4, had I gone the other direction, negative 4, I would have also gotten negative 6. Now I'll plug in negative 1. If I plug in negative 1 plus 3 is 2. 2 squared is 4. 4 times negative 2 is negative 8. Minus 4 is negative 12. So negative 1 all the way down to 12, which comes down here. And so I know if I'm 2 steps this way, there must also be a 12, negative 12 here because of the symmetry. And that would be if I had plugged in negative 5. So it doesn't matter if I go negative 3, negative 4, negative 5, or negative 3, negative 2, negative 1. I'm going to get the same answers just on the opposite side because of the symmetry. And the reason for that is that you're squaring. Every time you square, if you plug in negative 2 plus 3, you're going to get 1. If I plugged in negative 4 plus 3, I would have gotten negative 1. And either way, 1 or negative 1, when you square it, is positive 1. So you're getting the same answer in the end because you're squaring those two solutions. So that's symmetry. That's what it looks like. That's the parabola. It's upside down because of this negative. And so those are the things you look at and think about when you're trying to graph a quadratic using transformations.